Really nice being here, talking about my new project, Atoma Network, with the goal of bringing decentralized inference for trusted AI. All right, so I will start by explaining you what Atoma is. So at a high level, Atoma is a decentralized compute layer network focused for verifiable AI inference and privacy. So why is this relevant? Because with AI, smart contracts can leverage Atoma as an intelligence layer to actually become really smart, right? To be able to use AI inference as one more layer of compute. And along the line, we also want to give model owners and creators the capacity to monetize their model creations and to be able to actually have some revenue stream from like open sourcing their models, etc. So why do we think this is important? Why do we think this is important? So if you have been following the AI community, especially around large language models like ChatGPT and whatnot, there have been like two different ways to look at the space. So you have people like Jan LeCun, which is like someone really famous in AI, chief scientist at Meta, that proposes that AI models should be open source. So like knowledge, intelligence is actually publicly available for everyone. Whereas other people like Geoffrey Hinton, which is considered to be the godfather of AI from Google, he actually thinks that these models are too dangerous to be just publicly available, right? So you basically want them to, he prefers like these models are only like available to a selected few companies for safety and whatnot. Of course, for Web3 people like us, I think we can agree that open sourcing this sort of technology is actually quite relevant. And the good news is that like the shrink between like closed source models like ChatGPT on OpenAI and large language models and open source models like Llama from Meta is becoming like they are becoming actually quite close in terms of performance, accuracy, and whatnot. So basically, the open source community has been doing really excellent work, and we can have access to these models very, very cheaply by downloading them from the internet. So that said, like we can think of, if we want to use Web3 technology to foster open sourcing these models, what can we actually do? How can blockchains be helpful to tackle these sort of problems? So blockchains and Web3 in general, it's extremely good it's extremely rounded to allow for governance. So you can basically put like communities of people, users, to vote for, to propose new intelligence features that they want to see, etc. It's also very good, as I mentioned previously, for licensing and royalties, because this will be especially relevant if you are building a model. Usually training these models is actually very, very expensive. And you would like to have some sort of revenue stream by putting this capital upfront to have access to future, to the future. So this is one more thing that is relevant. On the other hand, blockchains, as Diogo mentioned, they are not suitable for heavy compute, right? It's not like you can run this AI on-chain. You cannot run it inside a smart contract. So to give you a sense of like the magnitude of how heavy these models are, like usually they require hundreds of gigabytes of memory to run a single inference pass, whereas like smart contracts, if you want to submit a transaction, you have to submit a few kilobytes at most, and the cost will be just enormous. So for example, very small models for digital recognition takes around like thousands of dollars, if not millions, if you want to do it on-chain. So we actually need to do this off-chain, and this is where Atoma wants to fit. So you can look at, so if you look at the two opposite ends, you have Web 2, where you have zero verifiability. You have to trust the API provider. On the other hand, on Web 3, you have very, very high trust guarantees by just running the compute on like a decentralized network of participants with cryptography and game theory at hand. On Atoma, we want to be in between, right? We can be something that can go from 0% to very, very high security or verifiability, if you want to say. And actually, this is basically the user has the capacity, has the chance to pick what is the amount of security, what is the amount of decentralization he wants to see on his application. So that said, like Atoma decouples the settlement, which happens on chain, and the heavy compute that happens on Atoma. And as I mentioned, users can choose the level of decentralization and therefore cost. So here is a diagram how we are planning how the architecture works. So on the right, you have like a Web2 user or like a smart contract on a blockchain. We are basically blockchain agnostic. You can just submit a prompt, but the prompt can be any input, right? It can be some numerical input. It can be text. It can be an image whatsoever. You submit this through Atoma. So Atoma, you'll have a bunch of nodes executing the inference. And these nodes will basically reach, like, you can have a single node running the inference, you can have multiple nodes running the inference, and they will be able to actually get to some sort of like consensus on the output, if the output was tempered or not. So if you have more nodes, you will have necessarily more security guarantees. And once the output is generated, this output can then be shared back to the user through like some Web2 API service, or can be submitted on-chain if the output is not too big. If it's too big, you can store it on some decentralized storage solution. And not only that, we also want to allow, for example, RAG, which is retrieve augmented generation, which basically you give more data and more context to the model, right? So you can provide like authenticated data from the internet, like a research paper or some protocol, governance, constitution and whatnot. And you can even run code as well, Python, Rust, Solidity, etc. So our vision for Atoma, we not only plan to provide this AI, but we also need to provide a substrate for the compute itself, right? So these models, they are heavy, and so there is a need for compute to become available online that can be decentralized and democratic along the players. So we want to bring idle GPU compute online. And actually, this, in my opinion, is also a very important point, because if you look at the landscape of AI, you have OpenAI, but OpenAI has a lot of competition from Google with Gemini, Anthropic, the open source community with Meta leading and whatnot. But if you look at the compute level, NVIDIA basically doesn't have any sort of competition, right? Like NVIDIA, they have a monopoly on GPU compute and whatnot. We also want to bring like data integrity and verifiable inference, as I explained. And privacy is also very important for us. We are very focused on privacy, but that requires some more work, both model and data privacy. So regarding our tech stack, as I mentioned, like we are basically integrating on blockchain. So we want to integrate the technology across major blockchains. We have building the infrastructure for the machine learning purely in Rust. So we are using some really nice Rust ML frameworks from Hugging Face. You might know. I think Rust is a great language and actually has good benefits compared to Python and like the general what people usually use like PyTorch, but I can explain that if there is any interest. And we have both CPU and GPU support. So on the GPU level, we actually allow for Metal and CUDA frameworks. And Metal, if you don't know, it basically allows to run like these models if they are not too large on your MacBook Pro. And therefore, like even if you have like a laptop, you can still provide compute to Atoma to run like these models. We are also exploring cryptographic primitives around multi-party computation, ZK, ML, even though it's still in its infancy and requires time to be able to run like ZK circuits for these very large language models. We are also exploring like trusted execution environments and etc. So to give you a sense, since this is a very early startup, to give you a sense of how the development is being done at Atoma, we have the deployment of smart contracts. So you can actually, these smart contracts are live even though we haven't publicly announced it. You can just make requests, like other smart contracts can call Atoma to have access to this intelligence layer. And we have integrated with leading open source AI models like Llama 3 and whatnot. And we are working on some like additional technology around no obfuscation, which is a method that we have to basically decrease costs and increase security using cryptography and some other primitives. And we also are in the process of integrating with like data storage solutions like IPFS and whatnot. So why I think this is cool? I mean, AI can lead to new like dApps and new applications in general. Diogo mentioned like derivatives for gas prices, and I think like something like having an intelligence layer available to contracts on chain to look into and make decisions based on the gas prices, like historical gas prices, could be a great application of this sort of technology. You can also have like autonomous agents, etc. NFTs, it's the most easiest but also exciting application, generating and minting AI-generated NFTs. You can even talk about like genetic NFTs that evolve over time with the on-chain activity of each user. We can talk about gaming and also DAO assistants, DAO AI assistants, like for DAO governance and for reputation mechanisms and whatnot. So you can think of like having just a Bored Ape, and if you have your AI with you, you can basically evolve, like this Bored Ape can evolve over time, right? So if you are doing a lot of on-chain activity, maybe the Bored Ape becomes really evolved and really excited. And basically you can have like your Tamagotchi on-chain. So to talk how we plan to put forth like these financial incentives. So Atoma, you will be able to provide compute, and by providing compute, you'll be rewarded some tokens, and you can actually accrue fees because you are just basically helping the network through like compute and security. But also, if you have, if you are you are basically building your own open source models and or even agents, and these open source models actually have interest for communities, they are aligned with a set of participants. That's also a possibility to accrue fees and rewards over time. And yeah, that's mostly it. And if you want to follow us on Twitter, we have also a website and GitHub. And thank you so much.
So just to make sure that I understood this correctly, you're quite similar to Render, like in the fact that you're allowing people to contribute their unused resources, but you take it a step further and allowing AI inference. Is that how you say it? Like you're allowing people to make conclusions out of the data that is being provided through the idle resources. Is that a correct way to frame it?
Yeah, I mean, so that's a great question. You are right. So Render is, as I understand, like they basically provide GPU compute for rendering like 3D like data and images and whatnot. We are on the other side, like providing this GPU compute for AI. And we are not necessarily a DePIN network because we actually provide the infrastructure for like to set up the node and run inference and the blockchain communication and whatnot, right? So you as a user, like it's not like I will rent your GPU to run some compute that I want. The GPUs are necessarily following some protocol, some logic, and this is kind of common to every node, every participant.
Thanks for a good talk. In the beginning, you had the slider between 0% verifiability and Web3, and so I'm understanding this as there, like so you're doing redundancy of the generation, and then So then that needs to be deterministic, and you talked like another slide about the data authentication. Like, can you elaborate on what you're doing there?
Yeah, that's actually also a very good question. So we do this through replication. So we replicate the compute. It turns out that if you do some basic probability, you will understand that a very little, like a small set of nodes is enough to get like very high guarantees. And yeah, like if you want to replicate compute, you need some sort of like determinism for the computation, right? Otherwise, you cannot replicate this. So there are a bunch of ways in which like AI workflows are not necessarily deterministic, especially LLMs where you have to do some sampling and whatnot. But you can actually enforce determinism through like fixing, like for each request, you can randomly generate the random seed for every node executing this with the same random seed, and and then you also have some concerns with like floating point arithmetic and whatnot. But there are ways to actually enforce determinism if you enforce like some constraints on how you are running the inference. And the other question was through like data authentication. Yeah, so the data authentication, the way that we are looking into it is more like as input, in the sense that if you want, say, to run like, imagine like you are a smart contract and you need to have access to historical data, right? So usually that needs to be sort of authenticated, and in that case, ZK makes a lot of sense. For example, for proving like the integrity of historical on-chain data. You can also use similar techniques for like data that is retrieved from the internet. If you want to have access to, say, a research paper, you don't want to make a reference that is incorrect to a given paper, right? And this is how we plan to do the integration. Yeah.
Any more questions?
Looks really cool. Just for a bit of clarity, so these execution nodes on this slide, does that represent kind of the compute that's being contributed by third parties? Yeah. Right, okay. So from a kind of execution standpoint, how do you distribute this inference? Like, is it per kind of context? Is it distributed beyond that? Because I mean, these are really high compute tasks that are pseudo real time in nature, right? It's not a 3D model being rendered and then appears moments later. It's something that there's direct interaction happening. So I'm just curious how that kind of latency is being catered for in the model.
Yeah, that's actually a very good question. So basically, the way that we are doing it is by we actually have some on-chain logic to do some sort of like load balancing, and we basically nodes have to register and they have to subscribe to what model they want to run. So it's kind of in advance who is running what and who is willing to run what. And so you keep basically a state of that on chain or in some other platform that is accessible and public. And then basically we have a mechanism that like a node selection. So let's say that you want to run compute for like, let's say in this case, a allometry model. You can basically look into like each, like we are dividing the network kind of in terms of hardware tiers, right? So if you have like more powerful hardware, you can run like larger models. If you have like a MacBook Pro, you can run like medium-sized model if it's quantized and whatnot. And so basically we keep like the cost of compute for each of these tiers. And basically, let's say that I want to run allometry, like which is 8 billion parameters, which is pretty medium size. So like the contract will see, okay, there is like all these tiers that are available to run the model, and so I will pick the cheapest one for this, unless the user wants to have very fast inference. In that case, you need to.
Sure. Yeah, look, it's really interesting.
Thanks. Yeah. Awesome.
We have time for one more question.
If you're replicating this compute, then you want to think about the incentives of not cheating. Like if someone else already ran it, I can just copy it. And so traditionally, you would think of like a commit reveal scheme, but that then takes time, and maybe that's too slow. Have you thought of like ZKP schemes to solve better for this commit reveal scheme?
Yeah, I mean, that's a great question, and you're right. I mean, we need some sort of commit reveal schema. And what happens is like so here in Atomo, you have two different ways of settlement. You have the output settlement. So imagine that you are a Web2 user, let's simplify it a bit, and you just want to have access to like, to the result of some compute, right? You might get the result right away, but you'll have like, say, some like on the UI or something like that, you'll have some like tick. If it's still gray, it means that it hasn't been settled on chain, right? When it turns green, it means it was settled on chain, and therefore you're set. But what happens is that you have two types of settlement. You have the output, the generation of the output, and that can be sent directly to the user, and the user can look at the output and look at it and see if it's satisfied with it or not. On the other hand, the settlement on the contract might take a while, but at least it's not like you are retaining the output from the user or from the application necessarily. And it turns out with a timeout system, you can actually enforce, like you have predictable time to finality, let's say. But yeah, so if you have multiple nodes running the compute, you have the output as soon as the fastest node finishes. But the guarantee will only be once the slowest node is finished.
Okay, thank you so much. Another amazing presentation.